Welcome to Math 1314, Section 4.4, and this is on logarithmic properties. So, taking a look here, we start off with our most basic property that we have, and that is log b of something is equal to an answer. And what that meant was that b raised to the answer as an exponent must equal to the something. This is the most basic property of logarithms, and everything else under this comes from this one basic property. So let's scroll down a little bit here. So log b of b is 1. So if you have log of the base, and that's the same thing on the inside, it's always 1. So log 10 of 10 is 1. Ln, which is log e of e, is 1. Well, why is that true? Well, 10 raised to the first power is 10. So anytime you have log b of b itself, it's 1. If you have log b of 1, that's 0. So log 2 of 1 is 0. Ln, which is log e of 1, is 0. And again, well, why is that true? Well, 2 to the 0 power is 1. 3 and 4, if I have log b of b, again, these b's match, of something, I get it back. And 4 looks a little strange, but equally true, and that is b log b of something is again that item back. Now put together, when have we seen functions composed together give us something back? Well, that is when they are inverses. So log b of x and b to the x, these are inverse functions, and they will undo what the other one did. Alright, so let's look. Problem 5 here, property 5, log b of a product. Well, anytime you have log of a product, you can expand that to the sum of each of the pieces individually. And when you have log b of a division goes over to subtraction. Now, why is that the case? Well, you might remember that with exponents. So for example, what if I have 2 to the 3 multiplied by 2 to the 5? Well, the way that you combine the exponents is the exponents add. And that's what's going on here. Remember, the answer to a log is an exponent. And here, whenever you have 2 to the 5th over 2 squared, you can simplify that by subtracting the exponents. And that's what's going on with properties 5 and 6. Question 7, we have log b of m to the something, and we get an answer. But first you have to ask yourself, how is 7, property 7, different from up here at property 3? Because I thought we already had log b of b to something and I get it back. Well, the difference is here in number 3, the base matches, whereas here in 7, this is what we do if they do not match. And so what happens is, if they match, log 5 of 5 squared, I get the 2 back. If I had log 3 of 5 squared, it's not 2. Well, what happens? Well, what happens is if they don't match, then the exponent jumps out in the front and is multiplied. So log 3 of 5 squared is 2 times log 3 of 5. All right, a couple more things. Log b of a sum and log b of a difference. There is no formula. There is no way to expand a log of a sum or a difference. It's only when it's multiplied or divided that there is a formula. And the last important fact from this section is something called change of base. Our calculator has log, which is log 10, and our calculator has ln, which is log e. But what if I needed to calculate log 5 of 17? How do I get that number? Well, we have something called change of base, and change of base says log b of something can be rewritten in terms of some logs that you do know. So log b of x is log a of x divided by log a of the base that we don't have. Now, since we have on our calculators log 10 or natural log, you can use either one and it's going to give you the same answer. So log 5 of 17 is log 10 of 17 divided by log 10 of the base we don't have 5. Or you could do this with natural logs, and you have natural log of 17 divided by natural log of 5, and either way you get 1.76037. Now if you're wondering, how do you know if that's right or not? Well, is an easy way to check. Log 5 of 17, we believe is 1.76037. Well, the way to check is take 5, raise it to that number as an exponent, and see if you get something that's almost 17. It'll probably be something like 16.99 or 16.98, and that's because I didn't write down all of the decimals. All right, let's look at some homework properties. All right, question 1. We have log 5 of 125 multiplied, that's a multiplication here, times c. Well, I just need to expand it. Log b of a product goes to a sum. So log 5 of 125 times c is log 5 of 125 plus log 5 of c. Now, looking at this, I'm wondering, could I simplify that somehow? Well, let's see, log 5 of 125 is something, so 5 raised to some power is that 125? Is that something I know? 5 to the 1 is 5, 5 squared is 25, and 25 times one more 5 would be 125. So yes, I can simplify that down to be a 3. Question 2. Let's see. Again, I have a product, and so I can at least expand the product as log 3 of the first plus log 3 of the second. But remember, there is no formula to expand a sum, and so we're stuck there. That's the end. Question 3. Question 3 is fairly straightforward. We have a log of a subtraction. And a log of a subtraction goes to log 6 of the top minus log 6 of the bottom. Question 4. Well, we have a difference, a quotient here. So I have ln of e divided by 3. So this is ln of e minus ln of 3. I don't know the ln of 3, so that just gets carried on. ln of e, well remember we had log b of b is 1. And log e of e is really ln of e, which is 1. So we can at least simplify that part. In question 5, we have log 10. Remember, when there's not a base, this is really log 10. So the number is just going to jump out into the front, and we get 7 times log of 4x plus 2. And again, there is no way to expand a log of a sum. Question 6 is not too bad if we remember a fact about exponents. And that is, when we have a nth root of something raised to a power, then this is really the inside part raised to the fraction m, the inside exponent, over the root on the radical. And so this piece, this 8th root of n to the 7th, I can rewrite as n to the 7/8. And now this is easy. The exponent jumps out into the front to simplify the problem. All right, in question 7, well, they want us to figure out, well, how big is log 5 of 19? Well, I don't know. Let's see. I know that if I put a number here, 5 raised to that number is going to be 19. All right. And so the question is, well, how big is that number? Well, I don't know. 5 to the 1 is 5. So 1 is not big enough. 2, if I put a 2 out there, 5 squared is 25, and that's too big. And so, whatever log 5 of 19 is, it's something between 1 and 2. Now it turns out it's 1.8295. Right? So, and again, that's because 5 to the 1.8295 is about 19. So, and that makes a little sense because 5 to the 1 is 5 and 2 gave me 25, so the answer should be closer to 2 than closer to 1. How do we do it? We use change of base, and so this is log 10 of 19 divided by log 10 of 5. Make the calculation and then round it to 4 decimal places. And then now they're showing you again to reiterate, well, why is this true? All right, well, what about log 5 of 6? Well, let's see. 5 to the 1 again is 5. 5 squared is 25. So I have 6, so the answer should be closer to 1. And it is. It turns out it's 1.1133. How do you get it? You use change of base. So log 10 of the 6 divided by log 10 of 5. We get the result, round it to 4 decimal places, And then finally, write how it works. 5 raised to this particular number is 6.